This video will look at just-in-time systems, and you'll see from the slide in front of you that this is part 4 out of 4. In other words, there are 4 videos in this class. Of course, each of them is important and each of them should be the subject matter of your study. So hopefully you will have viewed these and made your own notes from them. So let's look at this part. Here we're going to talk about converting to a JIT system, converting a more traditional organizational structure to a just-in-time system. So it's important here to get the approval and cooperation of top management. Their commitment is essential. If it's not driven from the top, it won't happen. So this should be a part of the corporate thinking. This should be involve the senior management of the organization, who have a commitment to it and will drive it through. They should be the champions of JIT. So next is to decide which parts need most effort. So look at the overall system within the organization and try to decide where JIT can be implemented. It may not be possible to implement it wholesale. It may not be possible to implement it right throughout the organization all at once. It has to be phased in, and it's necessary to look at different parts of the organization and see which parts are most suitable and can be brought online first and most easily converted to JIT. And that in itself is a good idea, because it then demonstrates the advantages of JIT to senior management and to anyone who perhaps may have doubts about the system. So deciding on which parts to go first is important. And of course it's also important to have the support of the workers, have support of line staff and line management, so that they don't feel threatened by the introduction of the system. So it should be explained in detail, and there should be briefing sessions and documentation supplied and question and answer sessions and so on, to try and allay fears and also to demonstrate the advantages of the system. So the best way to start it is probably to try to reduce setup times. Try to look at how machines are set up and how production systems are set up within the organization, and try to see or determine ways in which that could be streamlined. So look at it carefully. It's not scientific management. It's not time and motion, but there may be wastage in terms of the way machines are set up. It may be that making tools more easily available or passing information around the system is more easily facilitated by perhaps having a local area network or by having some sort of good communication system, and this will facilitate setup and reduce setup times. And that will reap benefits straight away and demonstrate the effectiveness of the system. So it's a question of gradually converting the operations, moving from perhaps the easier ones to convert to the more complicated, but introducing it step by step so it becomes part of the culture of the organization, and the line management and the line staff, as well as middle management and so on, they become committed to this way of working. And it's a way of working which simply identifies the customer as important. The customer orders then pull the work through the system. The customer order determines what should be produced and in what quantities, and that determines what machines, what personnel, and that also determines the amount of raw materials and components that will have to be bought in. And once they're bought in, they should be delivered straight to production and processed and pulled through the system right up to distribution and out to the customer. So there's no wastage and there's no unnecessary steps. For example, buying in raw materials, booking it into the stores, and then looking at jobs in the future and booking it out of the stores, booking the raw materials out of the stores, and so on. There's no need for that. If the system is properly configured and there is a relationship with the suppliers understand the philosophy and what has been attempted and what has been implemented, then there should be commitment all the way through the organization and to the suppliers outside of the organization, so that this sort of efficiency and this type of production system can be implemented. But gradually convert the operations, the more complicated operations within the business, perhaps being converted finally. So talk to the suppliers and get them to agree to make perhaps more frequent deliveries, perhaps smaller quantities, so that the quantities match those of particular customer orders. So there is no waste in terms of raw materials which are not being used. It's an efficient system. It's a lean system. But also prepare for obstacles. There will always be obstacles. People who don't want to cooperate, managers who don't see the need to change over the system, perhaps production personnel who are familiar with the existing production layout and system and don't want to learn a new one. There are always obstacles. They'll always appear within organizations. So be prepared with cogent responses and arguments to take on those criticisms and those points of view and persuade them of the benefits of the system, the efficiency gains, and the lack of wastage, the reduction in wastage that will occur if the JIT system is implemented. So the obstacles to conversion, well, management may not be committed, in which case it may not go through. It may be that top management is committed, but middle management and line management may make it very difficult. In fact, top management may find it impossible to see it through because of a lack of commitment further down the managerial chain. So there are obstacles. Management is not necessarily homogeneous. It depends on the strength of the senior management. It depends on the number of middle managers there are. It depends on the attitude of the trade unions, on the workforce, the attitude of the workers, of the line managers. It may be a change that's going to be resisted. So the workers and the management may not be cooperative. That's the point. Suppliers may not want to make regular deliveries of smaller quantities. It's not efficient for them. They prefer to make regular visits with large quantities, but regular in the sense that they are according to their schedules, perhaps their schedules which have been the ones historically used with that organization, and the suppliers may be reticent to change anything, so suppliers may not want to cooperate as well. So if the suppliers don't cooperate, then there will be wastage. There will be raw materials bought in which will not be used in the production process and which will necessitate a store to book in the raw materials and to book them out when they're required later. But that, of course, flies in the face of what JIT is about. Now, JIT in service. Well, the basic goal of the demand flow technology in the service organization is to provide optimum response to the customer with the highest quality service and the lowest possible cost. So that's what JIT is attempting to do. It's attempting to meet the requirements of the customer with the best quality at the lowest possible cost. And what it's trying to do is to streamline its activities in such a way as to bring about those efficiencies. So it's trying to eliminate disruptions. Disruptions in terms of relying on technology or machines which may break down or which may cause problems in terms of setup, which may require an extremely skilled staff. So there could be disruptions caused in many parts of the organization. There could also be disruption caused simply by workers not cooperating or management not cooperating, particularly junior management not cooperating fully with the changeover. Try to make the system flexible so that the system can be reconfigured when different types of products are required. So it may be changing tools on certain machines, and it's important that the workforce have the proper training and skills to enable them to do this. So try to reduce the setup and lead times by having economic runs, having appropriate batch sizes, but at the same time enabling the workers, the skilled personnel in particular, to be involved and to be able to switch over the system when required, so that they've built up an expertise in switching over from one type of production to another. They have learnt by doing, and this will reduce the setup costs. It's essential to eliminate waste. That's almost central to the JIT philosophy. So waste should be identified and eliminated. And waste could happen with, as I said, the suppliers delivering the wrong quantities of raw materials, so that not all of the raw materials will be used in production. Some will have to be put into a store and booked in and booked out. That's a waste, because that raw material is not doing anything. It's just sitting in the stores. So it's dead money. But it could also be waste in terms of the usage of machines. Some machines may be underutilized or not properly planned. Or there could be waste in terms of effort, because the whole production system is badly designed and there are breaks in the production system which necessitate manually moving products or components from one part to another. So look for waste wherever it is and try to eliminate the waste. And minimize work in progress. In a strict JIT sense, work in progress would be completely eliminated. There wouldn't be any. It would run through from start to finish, from the raw materials which are processed and worked on through various processing stages right through to dispatch and to the customer. So there is no work in progress. The work in progress is what's going through the machines. That is the work in progress. And that can only be done according to the speed of the various participating components, the machines and the personnel that are involved. But there's no work in progress in the sense of components sitting in a store waiting to be used at some future date. And it's important to simplify the process. Make sure that everyone understands that it is a very simple, albeit linear process from start to finish. And the organization can see the orders as they come in, and then the components, the sub-assemblies, the raw materials, everything at the start, entering into the production phase, going through the phase, and coming out at the other end as the completed product ready for dispatch to the customer. So it's a simplified process. It's a very simple one to understand. JIT purchasing, well, the new challenges are meeting manufacturing requirements. There is a problem about getting discounts and getting economic order quantities and so on, when in fact what the company needs are a lot less of certain components and raw materials, because they only want to produce to particular customer orders. They're not producing for stock. So there's a conflict here between the purchasing department, who want to place orders so they can get significant discounts and get particular leverage over the buying situation. But on the other hand, the JIT requirement that only the raw materials that's strictly required should be bought in. So there is a conflict there, and that can only be resolved by looking at net benefit. It's necessary to look at the advantages and savings from the JIT system versus the advantages and savings to be had by placing economic order quantities and negotiating discounts with suppliers. Changing from traditional thinking and practices. The traditional thinking and practice is to have frequent on-time deliveries of small quantities. The traditional method would be to have periodic deliveries of perhaps even large quantities, because that's the way it runs. But moving that to frequent on-time delivery of small quantities. Now, suppliers may find that difficult. Suppliers of raw materials and components may not want to make small deliveries on a frequent basis. It's expensive to run their lorries and their distribution delivering small quantities. There's extra administration, there's the shipping costs or the delivery costs, and also it's small quantities. They themselves have all the problems of completing the small quantity, packaging it up and getting it ready for delivery. So the suppliers are not necessarily committed to the JIT philosophy. They can see problems. They would much prefer to make their periodic deliveries of large quantities of raw materials and components and so on, and the company then puts them into a store and draws off the store as and when they require. So really asking the suppliers to make frequent deliveries of small quantities is really replacing the store within the business. Instead of having a stores, it has frequent deliveries from the suppliers. But clearly the suppliers may not like this. There should be long-term relationships with suppliers as partners. Try to get the suppliers to understand what the company is doing and try and get them on board and persuade them of the advantages of this and the long run advantages. They're going to have a customer for a longer period. The organization will be more competitive and likely to be in business for a longer period and so on. So try and win them over by making these points. Now there is something that often comes up in the literature called JIT 2. Well, JIT 2 is the practice of allowing vendors to manage some aspects of buying their product or services for the buyer. So JIT 2 is when companies start to link their databases together. So the company may be able to access the supplier's database. So the company knows exactly what the supplier has in stock in terms of raw materials, components and so on. And it knows it's got those in stock and is able to requisition it straight online from its reserves. So it's able to place the order online. It's able to it knows that the company has got that in stock. You can see what the company is holding in stock, and it can requisition deliveries. You can ask for deliveries at certain times. Now, this is when companies are so trusting of each other, but also so linked that they become part of this JIT system. It's not just one company operating the JIT system. Now, other companies may operate it, and there's, in a sense, networks of companies who are able to see each other's stock of components, raw materials, and the requirements for production, and they're able to draw directly off those and have them delivered. Now, the benefits of JIT systems, well, reduced inventory levels, even no inventory levels in the extreme. We've talked about that earlier. High quality goods, because once the machines are set up, properly tooled up, properly maintained, set up to work with the required tolerances, the quality should be good. It's still necessary to monitor the quality, but at the same time it should be good, because there is nothing to knock it off. If artisan work is required, if skilled workers are required to work on certain components, then it's a question of monitoring their work. But the work that comes off machines, perhaps computer controlled machines, that should be to a high quality. It should be flexible. It should be possible to change over the machines and the workflow to making something else. It should be possible to do this, to retool and make a separate order. Customers may require a variety of products, not just one product. So it's necessary for the organization to be able to switch over to meet other customer requirements as well. There should be reduced lead time. The lead times in deliveries should be reduced. Certainly the customers should be able to know when their orders are likely to be met, and it should be faster production. It should run through the system faster. There should be increased productivity as a consequence, because less waste, less intervention, more mechanization, more use of computer technology. There should be increased productivity throughout the system, and the workers that are employed should be skilled workers. They should have the capacity to do several functions, and they are really required to intervene in the event of a breakdown. But they may also be required to do some manual work which is of a particular dexterity that perhaps machines are not appropriate or are not sophisticated enough in terms of their dexterity to produce those items. So there should be increased productivity in a JIT system. There should be greater equipment utilization. It should be obvious to management which machines are being used, some of which may be used intensively, some not so. So it should be obvious as to where the priorities are put in terms of equipment, and but all the machines should be regularly maintained and should have proper preventative maintenance programs associated with them, because they are all important. It's just that as technology changes, some machines may become obsolete, and it may be necessary to replace those. There should be reduced scrap and rework, particularly if small quantities are being produced. Instead of running enormous batch jobs that are going to go into the stores and be stored away until customers perhaps buy them in the future, by meeting customer orders, current customer orders, the chances are the amount of work going through to meet particular orders may be small. So if there's something wrong with the order, it should be obvious that there's something wrong. But only a small amount has come through because the order is only meeting the particular customer order. So only that small amount will be scrap or will have to be reworked. Whereas if it was producing a large number, perhaps going to be stocked away in the stores, if it was producing a large number and an issue or a problem arose, a large amount of scrap may result. But because JIT only looks at the customer orders and tries to produce for to meet the customer order, then only a small amount would be scrapped or have to rework if something had gone wrong. So there's reduced space requirements as well. There's no stores required as such, so there's everything is more efficient. It's leaner production. There is no excess production or excess resources required. So space is used efficiently. There is pressure for good vendor relationships. The seller should have good relationships with the customer, but the seller to the customer should have good relationships. But as a buyer with its own suppliers, it should have good relationships. So it should communicate to its suppliers that it's running a JIT system and get them to understand what's required and try to get them to participate. But it should also have good relationships with its own buyers, with its customers. And the customers should know that the company is making good quality product and making it efficiently. And it's aiming to develop its reputation and its presence in the market. It's aiming to maintain that and develop it. There is a reduced need for indirect labour. There will be less workers required to deal with problems or scrap or reworking items or store work, moving materials around the premises. There will be less workers required for that because everything will be streamlined. It'll come straight in to production, be processed straight away and dispatched at the other end. So there's no peripheral work as such required. Now the elements of JIT, well, there's a smooth flow of work. That's the ultimate goal, that the machines and people should be working continuously and smoothly throughout the organization. There should be no waste. The workers should look out for waste, the management should look out for waste, and there should be programs in place to ensure that waste is minimized right from the outset, including, as I keep emphasizing, from the receipt of raw materials and components which go straight into production. There's no waste, there's no store required, and so on. So looking out for the elimination of waste. And there should be an emphasis on continuous improvement, quality improvements, speed improvements, efficiency improvements, and where intervention is required or where skilled workers are required to work on the product, ways in which improvements can be made should constantly be sought out and implemented. And try to eliminate anything that does not add value. If it doesn't add value, it should not really be there. Everything should really add value to the business. If it doesn't add value, it's dead weight. It's a pure cost. It should be a simple system that's easy to manage. It should be it should have a clarity about it. It should be easy for anyone to understand that the customer has placed an order and the raw materials are being processed right throughout the various stages, going to the dispatch and off to the customer. There's not so much a paper chain anymore, perhaps an electronic chain that will send out an invoice and will bill the customer and so on. But that's part and parcel of the production process. But it's a very simple system that's easy to manage. Use of product layouts to minimize moving materials and parts. So try to set out the organization so as to minimize having to physically move materials or components, or try to minimize movement. When movement happens, there are all sorts of issues that can arise with it. It can be errors, there can be mistakes, there can be accidents. So try to minimize movements. So once the whole production process is put in motion, it should run from start to finish, and it should run smoothly and efficiently from start to finish. As I said earlier, almost in a linear fashion. There may be components that have to be bolted on or added to the work, or sub-assemblies which are produced elsewhere within the organization perhaps. But they should also be produced efficiently, but then brought together efficiently later and added to the product before dispatch to the customer. And make sure that quality runs right throughout the system. This is total quality management, making sure that there's quality from the receipt of the raw materials, there's fast and efficient inspection of the raw materials to make sure they're good quality, through to the tolerances on the machines, through to whatever skilled work that workers have to do on the product, making sure there's quality all the way through and that it's properly monitored all the way through, to avoid having to rework or scrap components or the product itself, which is again pure cost. There is a process called Poka-yoke, which is a fail-safe tools and methods. It's designed as a fail-safe system. Some people say it's get it right first time and get it right every time. And that's what is generally taken to be meant by Poka-yoke. It's trying to avoid errors and avoid mistakes. It's trying to get it right every time and get it right the first time. It should not be experimental. When jobs are put through the system, there is no scope to try out systems and try them out and waste materials and waste time. Get it right first time, get it precise the first time, and get it right every time, so that the requirements of the task are broken down, clearly understood and clearly administered right throughout the system. There should be preventative maintenance, as I said. Waiting for a machine to break down so as to get the maximum usage out of the machine is not a good policy, because the machine breaks down, it's going to hold up all the subsequent machines and people who are waiting for the product to go through. So there should be preventative maintenance. Parts that are showing wear should be replaced, even though they're still working. They're showing wear, they haven't got long more to go, so they should be replaced. Good housekeeping. Well, by good housekeeping we mean that everything's accounted for. The management know exactly what raw materials have come in, they know exactly what's in the system, they know what work in progress, in other words, what is actually being processed at the moment, not the work in progress that we traditionally think of as semi-finished work in the stores. This is what is in the system and what's going through the system right now, and what is required by the customer at the end. So there's good housekeeping. They know where the tools are, they know where the equipment is, they know what's needed in the event of a breakdown, they know what the current job is, what the specifications are, what the requirements are. So there's good knowledge about the system. And the setup time is reduced because the workers are skilled in setting up the machines, and the machines themselves should be easy to set up. There should not be complex routines to follow. It should be easy to switch over the tooling on the machines. So the organization has flexibility. They're able to change over from one type of product to a different one. The workers should be cross-trained, as I said earlier. They should have the ability to perform different functions. If there's a failure in the system, many workers can go to try and get that failure fixed and get the system back up and running as quickly as possible, because they have training in different parts of the system. They're not just focused on one particular skill. They have perhaps two skills, or they're able to deal with two particular machines, or they're able to multitask in different ways because they've been trained to do so. And there's an ongoing program of training to ensure that their skills are up to date. And it is a pull system. The system doesn't have any fat in it. It's a lean system. There's no wastage. Wastage has been reduced. It's efficient all the way through, and the work is pulled through to satisfy specific orders placed by customers. So the customer order is pulling the work towards it, towards completion and delivery to the customer. So it's a pull system. A push system would be seen as inefficient. It's when management decide to produce a certain amount. There are no orders there. They're just deciding to produce a certain amount, and when the items are produced, they go into the stores and they sit there waiting for a customer to come along and order them. And that's seen as inefficient. The pull system is far more efficient. There are downsides associated with this. For example, seasonal demand, changes in quantities demanded at different times. Sometimes if orders are slack, rather than having people not doing anything, it's probably better to have them producing something, so some items go into stores. So we can imagine arguments against everything we've said. But these classes are on JIT and on the advantages and disadvantages of JIT. So we've emphasized what JIT is throughout these classes. It is a good idea for you to now go away and not just understand what JIT is, but also understand what the criticisms of JIT are, and to do some of your research yourself into the criticisms of JIT. But that's all we're going to deal with in this session. This is the last session in these 4 particular classes. So thank you for watching.